Hi, and welcome to our 124th test and measurement video. Today, we'll begin a series on the Pico 108 Vector Network Analyzer, or VNA, a new PC-based instrument that is once highly capable and yet, compared to a bench-type VNA, relatively inexpensive. Because like all VNAs, it is a rather complex instrument, this will be a multi-part series. Part 1, today's video, will consist of an overview, downloading the software and driver, and cabling the module and computer. First, let's consider conventional VNAs, what they do and how they work. Remember that a network in this context is not generally a computer line or WAN, or telephone network. A VNA is concerned with smaller systems such as conductors, components, circuits, and the like. It can, however, perform a time domain reflectometer analysis on coax or other media that are not over 100 meters long. Most often, VNAs are connected to two-port networks, particularly amplifiers and filters. They feed a signal into the input and analyze the signal at the output, then go on to characterize the device. They can also feed a signal into the output and read it at the input, which, as we shall see, is an important step in matching impedances for maximum power transfer. Early network analyzers used external signal sources, but now, as in most instrumentation, everything is within a single enclosure. Network analyzers fall into two categories. The Scalar Network Analyzer, SNA, measures amplitude only, while the VNA measures both amplitude and phase. Today, when we say network analyzer, we are generally referring to the VNA, as phase has become an increasingly important metric, especially in the higher frequency digital domain. To determine the phase, a reference signal is needed. For that reason, two or more receivers are used. Typically, the signals are down-converted in the manner of a super heterodyne radio receiver. The lower frequency signal is measured by means of a quadrature detector. The signal is then displayed and measured. Reflection and transmission data are formatted and interpreted by means of linear and logarithmic sweeps, log displays, polar plates, Smith charts, trace markers, and limit lines. All this makes for some sophisticated instrumentation. For example, Picotech has come out with two substantially less expensive PC-based VNA models. Online, the Pico 108 8.5 GHz VNA is priced at $8,255, and the 106 6 GHz model is $5,995. The two units are similar, except for the different upper frequency limits. The price reduction is possible because the PC-based VNAs, like PC-based oscilloscopes and spectrum analyzers, take advantage of the great display and processing capabilities of the user-supplied laptop or desktop computer. Since most people already own a computer, that part of the cost does not have to be figured in. PC-based instruments are very easy to hook up to the computer. First, you have to make sure your computer is compatible. And no, the Pico VNA unit won't work with the Mac. The computer has to be a Windows machine, either laptop or desktop. I am essentially a Mac person, so I had to buy this Microsoft Surface laptop. So, We'll consult the Pico Vna Quick Start Guide to determine system requirements. The processor memory, free disk space, is as required by the operating system. The required operating system is Microsoft Windows 7, 8, or 10, 32-bit or 64-bit. The required ports are USB 2.0, which is compatible with USB 3.0, and for display resolution, you need 1280 by 720 minimum. Don't be deceived by the small form factor of this PC. Consulting about this computer, we find it has plenty of memory and computing power with the latest operating system, Windows 10, and 16 gigabytes of installed RAM. The next step is to download and install the Pico software. You can obtain it from either the flash drive that comes with the Vna, or free of charge from the manufacturer's website at www.picotech.com downloads. Download and installation are simple. Connecting the Pico Vna is self-evident. To begin, make sure that the laptop is charging or fully charged. Then power up the Vna by means of the wall-connected 12-volt DC power supply connected to the power supply input on the back panel. Connect the Vna to the computer using the supplied USB cable. Power up the Vna by turning on the rocker switch on the back panel. At this point, the green power light on the front panel goes on, and you know your power connections are good. Then power up the computer. The Pico Vna icon on the desktop indicates the software installation was successful. Click on the icon to activate the Vna program. Now, the software drivers will automatically install in the Pico module. A dialog box may appear indicating that the instrument is not connected. Assuming that the green power light is on the module front panel, this is probably because the driver installation has not completed or one of the USB connections is not tight. Notice that without an instrument connected, you can run the Vna in demo mode. This, in conjunction with the Vna user guide, which in addition to the software is available at the Pico website, provides an excellent introduction to the Pico Vna. In part 2, we'll cover the field calibration process as performed by the user, which is essential if you want to achieve accurate Vna measurements. Thanks for watching. New videos are added periodically, so check back frequently.